In this lesson, we're going to configure access to your cluster, including authentication, and then we'll get a document via REST. Along the way, we're going to survey some related aspects of the API related to bucket and cluster management, and look at an aspect of Couchbase architecture that relates directly to the behaviors that we're seeing. So to connect to a Couchbase cluster, you're going to need to authenticate, and authentication has changed in Couchbase 5. With Couchbase 5, we have fine-grained, roles-based access control. This means that there are permission sets categorized as we see here. You can fine-tune user accounts around replication targets, particular nickel query operations, full text and data management roles, and even bucket-specific permissions. Of course, a user in this context is a composition of roles for a particular type of user in your application, not a specific user account. Your own client-side authentication is going to be happening through OAuth or OpenID or something of that sort. Now, the Couchbase SDKs abstract this by passing user credentials through an authenticator when you connect to your cluster. So how do you configure an authenticator? The password authenticator class allows you to create an authenticator and assign to it the username and password for the relevant user account that you've created in your server. The SDK, for convenience, supports a fluent style of method chaining. This single credential for your client-side user sets all the operations that are available to this type of user. If you're working with Couchbase 4, a classic authenticator is available. To connect to your cluster, first you need to pass it a set of one or more high availability URIs. These are the bootstrap URIs, a set of nodes that are known to be reliably available. The cluster object is created, and then from that point, the full cluster map is updated in the client. If you want to pass in a set of bootstrap nodes, you do so using a connection string in this format, Couchbase : and then a comma delimited list of the URIs. The configured authenticator is then assigned to this cluster. To connect to the bucket, well, if you have a authenticated and configured cluster, you simply open the bucket by name. This bucket object then exposes the data operations that we'll be looking at through the rest of these lessons: get, insert, upsert, replace, remove, and query. You can manage timeout and related concerns around your bucket using these settings so that you can throw exceptions as relevant if a nickel query takes longer than you wish, or if you want to set a durability interval, the microseconds to wait between reprobes of a presumably busy node. You can also manage your cluster and bucket references. There's a cluster manager that allows you to list available buckets on the server, create and remove a bucket, and get information about the status of your cluster. There's also a bucket manager that allows you to list, create, and drop either nickel indexes or view design documents for the MapReduce view approach to indexing in Couchbase. You can also call your info here and flush a bucket if flush is enabled, clearing all the data in that bucket. To get a document by ID, well, that's pretty straightforward. Your own code is going to get the ID from the client, pass it to the get method, and what you get back is a document object. This document exposes properties, error, value, flags, CAS or check and set, and token. Now, how these values are populated will depend on the particular operation in use, and we'll return to this concept a few times in the lessons ahead. When you get your document, the underlying value that you're retrieving will be in the value property of the document object returned in this code sample as a result. Because the native format of a JSON document in PHP is different than the string representation your client might anticipate, as we show here, we're throwing it through a JSON encode before we write it back to the response body. Couchbase Server is fast. Why is that? Well, it's a memory-first architecture. Our roots are in caching. All of your operations are served and acknowledged primarily from cache, exclusively from cache, depending on how you've handled your sizing. Your disk writes are append only. Whether it's a new document being inserted or a replacement. So let's visualize this. Imagine this write log, and documents are being continuously appended. So if a new document ID matching a prior ID is appended, it has the effect of replacing the prior document. So we pass in a few more. Document ID 2 is replaced. A third version of document ID 1 comes in, and then a get operation happens. So the get is always retrieving the most recent version of the document. As a result of this, appending a new document ID effectively inserts or creates that document, whereas appending an existing document ID replaces or updates that document. We'll come back to this concept a bit more later in the course. So what have we learned here? Well, first, Couchbase 5 supports roles-based access control. The SDKs support an authenticator which secures access based on a defined user account in your server. There is a classic authenticator available to support Couchbase 4 if you are using Couchbase 4. Your cluster is configured with a connection string of one or more Bootstrap URIs, but from the moment it's created, it's going to pull the most current cluster map and continuously keep updated with the current state of the cluster. You also assign the authenticator to the cluster, and then through that cluster you open your bucket by name, and it's the bucket that supports all of the operations with your data. The bucket get, as we saw, returns a document. All of the accessor methods through the bucket will return a document or set of documents, and the document exposes an error, the underlying value, potentially some flags, a check and set value, which is used for optimistic locking, and potentially a mutation token if that feature is enabled. In the lab for this lesson, you're going to configure the cluster settings and dependencies in the slim dependencies that we've introduced in the prior lesson. You'll also read an existing document using a get via a get route. Once you've played around with that a bit and feel like you've got the concepts in your hands, come on back. We've got a lot more to cover ahead.